Hello and welcome to a new section, Graphs, Geometry and Geographic Information Systems, where we'll explore about Python's capabilities in graph theory, geometry and geography. The first video of this section deals with manipulating and visualizing graphs with NetworkX. Here we'll show you how to create, manipulate and visualize graphs with NetworkX. NetworkX is installed by default in Anaconda. If needed, you can also install it manually with the command conda install NetworkX. It may take some time. Done. So you can see that it's already installed on my system. Now let's go to the Jupyter Notebook and import the packages NumPy, NetworkX and Matplotlib. There are many ways of creating a graph. Here we create a list of edges, that is pairs of node indices. So first we define the number of nodes in the graph. Each node is connected to the two next nodes in a circular fashion. Similarly, define the adjacent nodes. After this, instantiate a graph object with our list of edges. Let's say g equals nx.graph and pass it to the adjacent nodes. Let's check the list of nodes and edges of the graph and its adjacency matrix. Print g.nodes. So here's the list of nodes. And in a similar way, we print the edges. Here are all the edges. And now we check the adjacency matrix. Done. Let's display this graph with these two lines of code. Now, NetworkX comes with a variety of drawing functions. We can either specify the node's positions explicitly, or we can use an algorithm to automatically compute an interesting layout. Here we use the draw circular function that simply positions nodes linearly on a circle. Let's go ahead and see the graph. Superb! There's more to explore. Graphs can be modified easily. You can also add a new node connected to all existing nodes. For instance, have a look at these lines of code. Here we specify a color attribute to this node. In NetworkX, every node and edge comes with a Python dictionary containing arbitrary attributes. Now let's draw the modified graph again with this block of code. The code is quite self-explanatory with the components I added. This time we specify the node's positions and colors explicitly. At the end of this block of code, we draw the graph with Matplotlib. We can now see the new node added at the center with a different color. Let's also use an automatic layout algorithm. Nice!